Here is a question that should keep you up at night. What if time travel is not just possible, but inevitable? There is a paradox in physics so elegant, so disturbing, that even the greatest minds of the 20th century could not dismiss it. And once you understand it, you will never think about time the same way again. It is called the closed time-like curve, and it is baked right into the mathematics of Einstein's general relativity. Not as a loophole, not as a quirk, as a feature. Let me explain. In 1949, a mathematician named Kurt Gödel, who was actually Einstein's best friend at Princeton, discovered something that shook physics to its core. He found a solution to Einstein's field equations, the very equations that govern the behavior of space and time, that allowed for paths through spacetime that loop back on themselves. Imagine walking in a straight line through the universe and ending up exactly where and when you started. Not in space, in time. You leave on a Tuesday and arrive back on the previous Monday. Gödel showed this was not fantasy. It was math. Real, rigorous, peer-reviewed math. Einstein himself was deeply troubled by this. He spent his final years trying to disprove his friend's result, and failed. Now, you might be thinking, okay, but that is just theoretical. Nobody has actually traveled through time. And you would be right. But here is where it gets wild. We already know time travel to the future is real. Not theoretical, not hypothetical. Demonstrated, measured, confirmed. Every GPS satellite orbiting Earth right now experiences time slightly faster than you do on the surface because of the difference in gravitational fields. Their clocks tick about 38 microseconds faster per day than yours. If engineers did not correct for this relativistic time difference, your GPS would be off by about 6 miles per day. That is Einstein's time dilation, and it is as real as the phone in your pocket. Astronaut Scott Kelly, who spent nearly a year on the International Space Station, moving at 17,000 miles per hour, aged about 5 milliseconds less than his identical twin brother Mark back on Earth. Scott Kelly literally traveled 5 milliseconds into the future relative to his twin. That is time travel. Tiny, yes, but real. Now scale that up. If you could travel at 99% the speed of light, time dilation becomes dramatic. You could leave Earth, travel for what feels like 1 year to you, and return to find that 7 years have passed on Earth. At 99.9% the speed of light, 1 year of your time equals about 22 years on Earth. The faster you go, the further into the future you jump. This is not controversial among physicists. This is settled science. But the real paradox, the one that breaks people's brains, is about traveling to the past. And it starts with something called the grandfather paradox. What if you went back in time and prevented your own grandparents from meeting? Then your parents would never be born, and neither would you. But if you were never born, you could never have traveled back in time to prevent them from meeting. So they do meet, and you are born, and you do travel back, and the loop starts over. It is a logical contradiction that seems to make backward time travel impossible. Except physicists have found multiple ways around it. One resolution comes from the many worlds interpretation of quantum mechanics. Every time you make a change in the past, you do not alter your own timeline. You create a new branch of the universe. So your grandparents still meet in the original timeline. You just now exist in a different branch where they did not. Both timelines are real. Both exist simultaneously. Another resolution is even stranger. Physicist Igor Novikov proposed the self-consistency principle, which says that any action you take in the past was always part of the timeline. You cannot create a paradox because the universe simply will not let you. If you try to prevent your grandparents from meeting, something will always intervene. A flat tire, a wrong turn, a sudden rainstorm, to ensure that history plays out exactly as it already did. Your trip to the past was always part of the past. You did not change anything. You completed the loop. And then there are wormholes. Einstein and physicist Nathan Rosen showed that general relativity permits tunnels through spacetime connecting two distant points. If one end of a wormhole could be accelerated to near light speed and then brought back, time dilation would mean the two ends now exist at different points in time. Step through one end, emerge from the other in the past. Physicist Kip Thorne, who won the Nobel Prize and consulted on the movie Interstellar, showed this is mathematically valid. The engineering is beyond us right now, but the physics allows it. Here is what keeps physicists debating at 3 in the morning. We have never found a law of physics that explicitly forbids backward time travel. In most of physics, anything not forbidden is compulsory. That is not a joke. It is actually how quantum mechanics works. If a process is not forbidden by a conservation law, it will happen. So the absence of a time travel prohibition is deeply, deeply suspicious. Stephen Hawking proposed the chronology protection conjecture, basically arguing that the universe must have some mechanism to prevent time travel, because allowing it creates too many paradoxes. But he could never prove it. It remains a conjecture, not a theorem. The universe, as far as we can tell from the math, is perfectly fine with closed loops in time. And here is the final twist that will make your head spin. Some physicists, including Richard Feynman, have argued that particles are already traveling through time. Antiparticles like positrons can be mathematically described as normal particles moving backward through time. When you see matter and antimatter annihilating each other, one interpretation is that you are watching a particle reach a point in time, reverse direction, and head back the way it came. Time travel might not be a future technology. It might be happening all around you right now, at the quantum level, in every atom of your body. The question is not whether time travel is possible. The question is whether we will ever learn to do it on a human scale. And if someone from the future already has, would we even know? If this paradox melted your brain even a little bit, subscribe for more, because the universe has way more impossible